Hello everyone, welcome to the video for staying engaged while we've gone remote for a couple of days. I just want to go over a couple of things that we've done to this point in this semester and just keep it fresh for when we get back. So what we've covered so far to this point, we have the PATT System introduction where we went over the number of lab benches and things like that. We did some manufacturing terms where we talked about the process variable, the controlled variable, set points, disturbances, actuators, things of that nature. And then we got pretty deep into the control system. We looked at a PLC, the HMI we've been using, and the VFD primarily. We've done our P&ID diagrams, which are piping and instrumentation diagrams. And then we've also done the power systems drawings of the inside of the cabinet, as well as some of the stuff associated with the outside of the cabinet. More importantly, what I'd like to talk about is what we've done in the lab with going online with the PLC, uploading and downloading, or upload and download. And then we're going to get into the two main PLC programs that we introduced right before we took a break and go over some of the VFD parameters associated with those two programs. So the PATT system, we should be familiar with the lab setup as well as the communication and addressing. So we got 3 lab benches total, 9 lab stations, how many pieces of equipment, and the types. So we have 9 PLCs total, 9 VFDs total, and 9 HMI screens total. As far as the software used for that, we should be familiar that it's RS Links Classic. So RS Links Classic is our Ethernet communication software. It could be used as a troubleshooting tool so that we could see all of the IP addresses in the lab station and basically what we can communicate with, whether it be on the network, and we could see it, or if it's not on the network, then we won't be able to see it. So how do they communicate? We just covered that. So Ethernet communication. Our subnet and lab is 255.255.255.0. So that sets the IP address scheme up to be the first 3 sets of numbers using binary to decimal coding and giving us the 192.168.1 as our network. And then from there we identify our pieces of equipment. Software for communication as well as other softwares are things that we're going to talk about here as well. So the first one we're going to cover is when we go online with the PLC, what software are we using? So we're using RS Logix 5000, which is essentially primarily used for our PLC and the interaction with the PLC. So some of the areas in the program that we should be familiar with. The controller status box, which is where we can go online with the PLC. Once we are in that box, we can select if we want to upload or download. We could also change the controller from run mode to programmer mode and control things from there as far as if the controller is looking for inputs and outputs or the status of the controller. Is it talking? Is it ready to accept inputs and outputs? Is it ready to execute those commands? And then the controller organizer box, which is the tree down on the left, typically across the left side of the program, where we can find our main PLC program. We could also find our main program tags, which is all of the programming bits for inputs and outputs, as well as internal control relays and things of that nature. We could also find our VFD communications path. So if you scroll all the way down to the bottom of that controller organizer box, you'll see the Ethernet communications and the drivers, or essentially the other pieces of equipment that we've set up to talk through there, which is primarily just our VFD. You could also see the hardware configuration where it shows you the CPU designation, which is typically slot 0. And then we have in slot 1 our discrete inputs and outputs, slot 2, which would be our analog inputs and outputs, slot 3, which we have our internal counters, and then slot 4, which is our remote or external card, which is our HART communication card, which again, HART stands for Highway Addressable Remote Transducers. That's basically where we have all of our sensors tied to. And then we should also be familiar with, at this point, where we can find the different types of programming bits. So we have our XIO, our XIC, which are our normally open and normally closed contacts. We also have our output energized coil, and then we have our math and compare function blocks in those tabs as well. That would be located right across the top of the PLC program inside of RS Logix, and right above where we would typically see our ladder diagram for our PLC program. All right, what is this program used for? We typically are using it to interface and program the PLC. And when do we upload or download? So anytime we want to get a program out of the PLC or even the VFD, we're always going to upload information out of those components, and we're going to download new information into those components. All right, the two main programs, or the two main PLC programs, we have the HMI program, which has virtual inputs that control the valves. Those are all labeled toggles, so toggle 01, toggle 02, toggle 03, and toggle 04 are associated with controlling the solenoid valves. They also have this program also has virtual start and stop inputs. Many function blocks for sensors and signal calibration are used, and then we send and receive inputs and outputs to the HMI through Ethernet communication. So that's the reason why we don't see as many hardwired inputs as we will with the push button control. So the push button PLC program has physical hardwired inputs and outputs for the valves. Although the PLC program for the HMI has hardwired outputs for the valves, there is no physical hardwired input for those valves. All right, we also have a physical hardwired start and stop commands or start and stop buttons for the PLC program that works through the push buttons. We have a normally open green push button that's used for start command, and then we have our physical two-position selector switch, which is used to enable the VFD and also start or stop the pump. When we get into the building of the on-off level control, one thing that we are going to have to do, and I'll show you that in a separate video, is how to actually create some function blocks inside of the programming so that we can reference the DP level to PV value in order to do the on-off level control with this program. So it does not exist when you guys get it in lab, but we are going to give it to you and show you how to add those in. All right, so some information here on building the on-off level control program and design. So essentially what we're doing is we're bypassing the start and stop commands, and there's a little bit of information there. I'll have this PowerPoint up for you. I just want to get through the video here and tell you that we're going to use a less than and a greater than block for our start and stop commands respectively. And we're going to reference DP level to PV as the internal information to the controller as source A in both of those. And then in source B is where we put our static or our constant number, which is our actual set point. All right. One thing that I really like to touch on that it's kind of got cut short in lab is changing the VFD parameters. So the reason why we're doing this is because the VFD is set up to look through its COM port when we're working through the HMI screen for the start source and speed reference. So when we have that PLC program in there, it's anticipating getting information through Ethernet communication. When we put the PLC program that works with the push buttons, we have to go into the program, which is CCW, and upload the entire drive. We should be online and connected to the drive when we make these changes. And we want to change our start source to 3-wire and our speed reference to 0 to 10 volts. All right, so trying to keep it as short as possible and give you guys some information to stay engaged with. And I look forward to getting back next week.